Determine whether the system of linear equations is inconsistent or dependent. If it's dependent, find the complete solution. All right, so I'm going to turn this into a matrix first. So I'm going to go -2, 6, -2, -12, 1, -3, 2, 10, -1, 3, 2, 6. All right, now I'm going to move this down and move everything up so I can work with just the matrix. All right, so what I want to do is I want to make that 0. So I'm going to make that 0, and I'm going to do that by just adding row 2 to row 3 and then replacing row 3. So this will give me that 0. Oops. 0. This is 0. And this will be 4. And 10 plus 6 is 16. Well, that was convenient, mainly because we're going to need 2 zeros here anyway, so that works out nice. So then I have 1, -3, 2, 10, and -2, 6, -2, -12 again. All right, what I'm going to do next is I need to get a 0 here. So I'm going to take this row and add it to 2 times this row. So I'm going to take row 1 and add it to row 2, and that will replace row 2. So we're left with -2, 6, -2, -12 stays the same. And then I get -2 plus 2 times 1, which is 0. So there's a 0 here. 6 minus 2 times 3. So it's going to be 6 minus 6, which is a 0 again. And then I end up getting -2 plus 4, which is 2. And then -12 plus 20, which is 8. And then this is still 0, 0. And you know what? I'm going to actually multiply 1/4 by row 3 so I can make things a little easier. So 1, 4. Now, and in order to get things into reduced row echelon form, I need to, because these are both have 2, so I need to actually get rid of zeros all the way across to here, well, at least to here, to see if it's going to be inconsistent or dependent. So I am going to take row 2 and subtract it to 2 row 3 and replace row 3 with that. So I end up getting -2, 6, -2, -12, 0, 0, 2, 8, and then 0, 0. 2 minus 2 is 0, and then 8 minus 8 is 0, because 2 times 4 is 8. So this right here, if I had 0, 0, 0, and then a number, that would mean that it was inconsistent and that there would be no solution. But since it's 0, 0, 0, 0, this is going to be dependent, which means now I got to find all the solutions. So to put it in true reduced row echelon form, I need to make a 1 here and I need to make a 1 here. So what I'm going to do is I'm going to multiply -1/2 to row 1, and I'm going to multiply 1/2 to row 2. So row 1 multiplied by -1/2 is going to give me 1, -3, 1, 6. And then 1/2 times row 2 is going to be 0, 0. 2 divided by 2 is 1. 8 divided by 2 is 4. And then 0, 0, 0, 0. And then actually, if I want really reduced row echelon form, I can actually reduce this to become a 0, because you want as many zeros as you can. So what I'm going to do is I'm going to take row 1 and subtract it to row 2, and replace row 1 with that. So I end up getting 1 minus 0, which is 1. Negative 3 minus 3, 0 is negative 3. 1 minus 1 is 0, and then 6 minus 4 is 2. And then I get 0, 0, 1, 4, 0, 0, 0, 0. Now this is in reduced row echelon form mainly because there's zeros everywhere I can, and right here I can't reduce it because there's only zeros underneath it. So this is reduced row echelon form. Now I can actually create my answer. Well, according to this row right here, this says z equals 4. So I know that z equals 4. According to this row, I know that x minus 3y equals 2. And I can solve for x, and I get x equals 3y plus 2. So my answer actually becomes, well, I know that z is 4. So this is 4. And I have x as a function of y here, but I don't have a y, so I know y is going to be the variable I can choose, so that's going to be t. And then x becomes 3t plus 2. And that's my answer.